Hi everyone. Today we're going to study natural and common logarithmic functions. First, let us define natural logarithmic functions. The function f of x equals ln x is the natural logarithmic function with base e. Thus, the log of x with base e equals ln x, where x is greater than 0. It means x must be positive. This f of x equals ln x can be written as y equals ln x. And this function is equivalent to the exponential expression x equals e raised to y. Next, let us define common logarithmic functions. The function f of x equals log x is the common logarithmic function with base 10. Thus, log x to base 10 equals log x, where x is greater than 0. It means x must be positive. There is a note: when the base of the logarithm function is 10, we call it the common logarithmic function, and the base is not shown. Likewise, if the base of a logarithm is not shown, we assume it as 10. The f of x equals log x can be written as y equals log x. And this expression is equivalent to the exponential form x equals 10 raised to y. Let's have this example 1. Rewrite in exponential form and find x to 3 decimal places. Letter A, log x equals 3. Letter B, ln x equals 2. Let's begin with letter A. Take note that the log x equals y is equivalent to x equals 10 raised to y. It means to say this log x equals 3 is equivalent to x equals 10 cubed. Simplifying this 10 cubed will give x equals 1000. And this is the value that is required for problem A. We will copy this opposite problem A. Here we go. Now, let us answer problem B. ln x equals 2. We know that ln x equals y is equivalent to x equals e raised to y. Thus, the ln x equals 2 is equivalent to x equals e squared. And this e squared, using calculator, we will get the value x equals 7.389. And this is the required value for x. We will copy this opposite problem B. Here we go. So we are done with our example 1. These are the final answers. Let us have example 2. And this is solving logarithm inequality. So the problem is to solve for x. The inequality is the log of the quantity x minus 1 then plus the constant 2 is less than the log of the quantity 2x minus 5 and then plus the constant 2. For our solution, let us copy again this inequality down here. And the next step is to subtract positive 2 to both sides of the inequality. We can see that both sides have the constant 2. So if we subtract 2 to both sides, the constant 2 here will be cancelled out. And then let us copy the remaining logarithms on the next line. The next is, we will put all logarithms in one side of the inequality. Let's say we will put this right side logarithm to the left side. So what we will do is to subtract the log of the quantity 2x minus 5 to both sides. So here we go. The log of 2x minus 5 is subtracted to the left side and to the right side. Look at our right side. We have the same quantity being subtracted, so we will cancel out the right side and this becomes 0. Next is, let us simplify our left side where we have two logarithms. Let us remember that the log of a quotient a over b equals log of a minus log of b. In the same way, we can interchange this idea that log a minus log b is equal to the log of the quotient a over b. So simplifying our left side of the inequality, we can simplify the expression here into log of the quotient x minus 1, that is the numerator, over the denominator 2x minus 5. And this is less than 0. To simplify this line here, let us remember that log x equals y is equivalent to x equals 10 raised to y. To extend this idea, we may write also that the log of x less than y is equivalent to x is less than 10 raised to y. It means to say, this expression here can be simplified further into x minus 1 over 2x minus 5 is less than 10 raised to 0. If we simplify the 10 raised to 0, we will get 1. And from here, we're going to solve for x. Let us cross multiply the denominator to our constant on the right side of the inequality. So 2x minus 5 times 1. Let us continue on this side. So we will have x minus 1 is less than 2x minus 5. Now let us solve for x, putting all variables on the left side and all constants on the right. So this 2x here, we will transpose on the left side. From positive, it becomes negative. And this negative 1, we will transpose also on the right side. From negative 1, it becomes positive 1. So we have now here x minus 2x is less than negative 5 plus 1. Simplifying our inequality here, on the left side, x minus 2x will give negative x is less than, the negative 5 plus 1 is negative 4. Let us multiply this inequality by negative 1, and the rule says multiplying by negative number makes the inequality sign reversed. So the inequality times negative 1. This negative x times negative 1 will give positive x. And this less than sign becomes greater than. And then negative 1 times negative 4 will give positive 4. So we have our answer, x is greater than 4. This is our final answer. I hope you learned something from this video. See you again next time.